is Miss Shannon, and I am here from the Walworth Sealy Public Library, and I am here today to do a science experiment. So the experiment that we are going to be doing today is called walking water. And so let's have some fun and get started. The materials that you will need for the walking water experiment is 5 clear glasses. If you would like to do a smaller version of this experiment, you can do it with 3 glasses. So I have my 5 clear glasses, and we also need water, food coloring, a spoon for stirring, and paper towel. So I'm going to go ahead and I'm going to fill up 3 of my 5 clear glasses with water. So I filled mine about 3/4 of the way full, and you want to try to get the glasses as even level of water as possible. So I have my 3 glasses that are full of water, and now I'm going to add food coloring to these 3 glasses. I'm going to be using red, blue, and yellow today. I'm going to put 5 drops of food coloring into each one. And now we're going to stir the food coloring in. Alright, I'm going to put my blue at the very end, my yellow in the middle, and the red at the opposite end. And I have 2 empty glasses in between. Alright, so now we're going to take our paper towel, and I'm going to cut off just about an inch or so at the bottom here so that they're not quite so long. This is optional. My glasses are a little bit shorter, so I'm hoping that will help. So we're going to take our paper towel and fold it in half once, and then fold it in half again, and then fold it lengthwise. So now your paper towel should look like this. And we're going to repeat this process so that we have a total of 4 folded pieces of paper towel. Let's fold it in half once, twice, and in half one more time. And so now we're going to take them, and I'm going to put one end in the blue and one end in the empty glass. And so I cut a little bit off the bottom so that they would sit in my glass and they would not have a large bridge between the two. And again, you want to make sure that the bridge between these two is not too awful tall, because it'll make the process a little bit harder. And you want the space between your glasses to be even. All right, so our experiment is set up, and now we have to wait and see what happens. So if you want to take this time to make a hypothesis for what you think will happen based on the title of this experiment, Walking Water, and the experiment that we have set up. So write down your hypothesis, and we'll be back in a little while to see the result. See you soon. All right, welcome back everyone. It has been 7 hours since our experiment has started, and this is our end result. So we started off with 3 glasses, one with red, one with yellow, and one with blue. And then we had 2 empty glasses, and we can see now that these 2 glasses now have liquid in them. And note, we have green and orange when we started with red, yellow, and blue. So we're going to talk about how we got those colors and how our water walked up the paper towel, over and back down the paper towel, and deposited the water in our once empty glass. So we're going to talk about how our water walked up our paper towel first. This is possible through a process called capillary action. Capillary action is the ability for water to be able to move in an upward direction against gravity in a narrow space like a tube or a porous material like our paper towel. This is possible through cohesive force, adhesive force, and surface tension. A cohesive force is the attraction of molecules of the same material. A great example of this is water. So water is sticky, and it's sticky in the sense that its molecules, they like to stick together. So if you take a little bit of water and you pour it on a table, you'll notice that the water clumps together and it doesn't spread out. So the water clumps together, it likes to stick close, and so that's how our water is sticky. And you'll notice that it forms a water droplet. So with cohesive force comes surface tension. So if you take our water droplet, the top of our water droplet has surface tension, and surface tension holds the surface together. An adhesive force is the attraction between different molecules. So our water here, it's attracted to the fibers in the paper towel. So we're not going to go into the specific steps of each force and its process, but know that between a cohesive force, an adhesive force, and surface tension, these 3 things work together to allow our water to walk up the paper towel and back down the paper towel in the process of capillary action. Capillary action can also be found in nature. Can you think of maybe something that would use this process? Plants. Plants use capillary action every day. Do you ever wonder how water gets to the very top of a plant? It uses capillary action. So water is sucked up by the roots of the plant in the soil and is drawn up to the top of the plant using capillary action. So this experiment that we did today, we can see this in nature every day, which is pretty cool. All right, so next we are going to talk about how we got green and orange when we started with only blue, yellow, and red. So this has to do with primary and secondary colors. So blue, yellow, and red, these 3 colors are all primary colors. And primary colors are the base of all our colors. And when 2 primary colors are mixed, then that forms a secondary color like green and orange and also purple. So our blue here, the water walked up the paper towel, back down the paper towel, and deposited the water in the once empty glass. And our yellow here, the yellow water walked up the paper towel, back down the paper towel, and deposited its water into the glass. So when blue and yellow mix, these 2 primary colors, they form the secondary color of green. So this process is the same over here. When red and yellow mix, which are 2 primary colors, they mix to form the secondary color of orange. So now we have a little bit of the rainbow before us. So that is the science behind walking water. I am so glad you were able to make it today. I hope you are able to do this experiment at home, and we will see you soon. Thanks for joining me. Bye!